Welcome, dear students. Today, we will learn about the fundamentals of AI. Presenting before you the basic introduction of artificial intelligence. This subject is covered in the sixth semester of branch CSBS, and in this video, we are going to see about the basic fundamentals and the initial terminologies for AI. So let us move ahead. As we all know, the trending term and the most coined term in current era is machine learning. But the machine learning indeed is a subset which has been derived from AI. AI, dear students, is the superset. AI refers to those programs which are not explicitly programmed and which learn and which reason like humans. Machine learning is a subset of artificial intelligence, and it also refers to the ability of algorithms which can learn themselves. And deep learning further is the subset of machine learning in which we create a dense neural network which can learn from vast amount of data. So here this hierarchy shows us the levels and the organization of AI, ML and deep learning. Enthusiast who learns about artificial intelligence will eventually understand what are the various areas where AI can be applied. The diagram which you are looking here on the screen also contains some topics which are the important topics covered further in the syllabus of AI. AI is used to create the neural networks. Neural networks are the building blocks of machine learning. AI also make use of planning. Planning and search strategies are extremely important when we study AI. AI can be used to design robotics. AI can be used to develop machine learning. AI can also be used to design natural language processing systems. AI can be designed to develop perception. AI can be designed to develop knowledge-based systems and cognitive systems. So out of all these terms, we can also conclude that the five major areas which require use of AI are reasoning, learning, problem solving, perception, and linguistic or semantic intelligence, which refers to natural language processing. In this slide, we can see the various goals that AI system can accomplish. Talking about the summary of AI, AI system is designed to create expert systems, which means that a system capable of doing any action on its own is an expert system. And the goal is also to implement human intelligence in machines. The machines not only refers to robots or computer softwares, they can be embedded systems, they can be IoT-based devices, they can be the wearable devices and every possible software and hardwired program that we can imagine. Therefore, by using these concepts, we can make use of AI in problem solving and in decision making. We can also improve healthcare and medicines by intelligent healthcare and smart healthcare. We can encourage creativity and innovation by using design thinking approaches of AI. We can also advance towards machine learning and deep learning. AI can be used to develop robotics and automation. AI system can assist in planning as well. AI can help to achieve general intelligence, which is termed as generalization. AI system can support continuous learning. It can also enhance social intelligence and it can represent knowledge. And this term knowledge is a very important term when we talk about artificial intelligence. So let us dive deeper into knowledge in the next slide. Intelligence requires knowledge, which means that knowledge is a prime requisite to design an intelligent system or an artificial intelligence system. But there are some constraints with knowledge. Knowledge is huge. Knowledge is difficult to characterize. Knowledge changes rapidly and knowledge can be complicated. And therefore, the knowledge representation process play a very important role in designing an artificial intelligence system. And this knowledge representation combined with all these following techniques to develop a AI system. A AI system can be designed by using deep learning, computer vision, by generative adversarial networks, Swarm intelligence. This is a very interesting genetic algorithm and AI area. Then fuzzy logic, machine learning itself, recurrent neural networks, evolutionary algorithm, again a genetic algorithm, quantum computing. This, dear student, is the future of computing. Then Bayesian logic, which make use of naive Bayes classifier. Then natural language process, CNN, transfer learning, expert system, and explainable AI. And dear students, all these topics are itself a big domain of artificial intelligence. You can research further about these topics and learn as per your niche and gain more of the in-depth research in the topics. I'm leaving it over here only because not all the topics will cover our syllabus further. So let us move uh, ahead with this knowledge representation. Why are we using knowledge representation? We are using knowledge representation to solve some of our problems. So we now encounter the term problem. Problem solving in AI is a process with which we generate the solutions. Okay, so to obtain a solution, we are applying problem solving. Problem means problem where we have to achieve some goals. Problem contains some set of objects and set of operations. The problem word again leads to the concept of problem space. Problem space is the set of all valid states on which we can apply some operations and we can reach our solutions. Now, here again we are learning one more term which is called as search. Search means the complete solution for the problem space. The search is done with the help of control strategies. For example, the depth first and the breadth first search strategies are known to us. So talking about the depth first and breadth first search, we load the tree concept in our memory. Okay, so the tree can be one possible representation of problem solving, and graph can also be the another possible representation of problem solving. So in the coming topics of AI, we will move with the help of these two data structures for problem solving. The terms which you are observing on this slide have been taken from the book Rich and Knight, second edition. So I usually refer this book for all my students to understand AI. So to further understand the concept of problem solving, let us take the example of tic-tac-toe game. Tic-tac-toe game applies search strategy. And अभी हमने previous slide में देखा था that we are applying search for solution for getting the goal solution of our problem. So in the game of tic-tac-toe, let us assume that there are two players, noughts and cross, and the cross makes first move, and after the first move, eventually in the eighth pass, the X can move the game. So in the screen, you're observing seven states. Seven states have been changed by the player X to win the game. So these set of seven states is called as the search space. And what are the possible situations when X can win the game? There are three possibilities for X to win the game. X can achieve the pattern like this, horizontally or vertically or diagonally. Okay, so when we are talking about problem solving, it is very important to understand the search space and what are the possible conditions when the search can be win by the element. In this slide, we are only observing the possible states. Let us say that we have our game like this and we have reached this state in the tic-tac-toe game. Then there are possibilities that a player can encounter any of the three actions in his game. The player can take any of the three actions to further move in his game and win the game. So this is all about the concept of problem solving and search space. I am leaving some topics here in the homework. Regarding problem solving, I would suggest all of you to please understand the four problems: missionary cannibal problem, water jug problem, monkey banana problem, and n queens problem. And along with these, please study about what are ethics, AI ethics, and what are the basic principles of AI. This is all about for the basic fundamentals. In this video, I will bring some more interesting topics in the coming videos. Please stay tuned. Thank you.